Hello students, today we'll do the calculus and the most important thing is that some expected question which are important for the entrance examination, as well as we'll do the and some important concept based question on which we'll proceed today. Okay, so let us start the calculus, and remember one thing, calculus carries about 30 to 37% marks in the entrance examination, thinking about the last 3 years analysis. So let us expect it is one of the most important part for any entrance examination paper, and there are a lot of shift, a lot of papers are there. I think calculus carries the very much weightage in the entrance examination paper. So let us start. Let's start with the calculus. First question, let x to the power k plus y to the power k equal to a to the power k, a comma k greater than 0 and dy dx equal to minus of y by x whole to the power 1/3. These type of questions are very easier to understand, and let us solve this sum. What to do? In this case, let us do the differentiation of x to the power k plus y to the power k equal to a to the power k. So you are getting k x to the power k minus 1 plus k y to the power k minus 1 into dy dx equal to 0. So dy dx equal to, we can write this as minus of x by y whole to the power k minus 1. So let us do one thing. Therefore, we can write this as dy dx plus x by, just a minute, x by y whole to the power k minus 1 equal to 0. Also, given that dy dx plus y by x whole to the power 1/3, so from this case we can say k minus 1 equal to, what is coming here, 1/3. So k equal to, this is coming to be k minus 1 equal to 1/3 minus 1/3, therefore k equal to 1 minus 1/3 equal to 2/3. This type of sums are very easier to understand. Okay, and whenever if we can get this type of sums, so prompt will answer the question. But remember one thing, continuously I'm telling you, calculus carries one of the most important part for entrance examination. Let us do the next sum. The value of c in the Lagrange's mean value theorem, that is the MVT, for which the function fx equal to x cube minus 4x square plus 8x plus 11. So everybody, this sum is very easy sum to understand, and this type of sums are coming in entrance examination regularly as well as board examination also. So what will you do? F dash x equal to, what is there, 3x square minus 8x plus 8. Actually, it is a Lagrange's mean value theorem or first mean value theorem based. So here f0 equal to, what is there, fx equal to x cube minus 4x square plus 8x plus 11. So f0 equal to 11, and f of 1 equal to what? We are getting 1 minus 4 plus 8 plus 11, that is coming 16. So according to the first mean value theorem, that is the Lagrange's mean value theorem, f1 minus f0 by 1 minus 0, we are getting 16 minus 11 by 1. That is coming to be f dash c. F dash c is here 3c square minus 8c plus 8. Therefore, we can write this 3c square minus 8c plus 3 equal to 0. C equal to minus b plus minus root over b square minus 4c by 2. Whenever we are getting this type of easy based sums, will prompt answer of this question. Okay, so we are getting 8 plus minus 2 root 7 by 6, that is 4 plus minus root 7 by 3. But x belongs to, here it has been given that x belongs to 0 to 1. Between 0 to 1 there is only one value, so c equal to 4 minus root 7 by 3. Here C is 4 minus root 7 by 3, option number B. In this way we'll proceed. Okay, let's go to the next sum. This type of sums are some conceptual based question. First, let f and g be the differentiable function on R such that f of g, that is a composite function, is the identity function. Everybody, identity function क्या होता है? What is the identity function? Identity function is f of gx equal to x. It means f of gx, we can write this here also, and representation is a lot of representation. So let us differentiate on the both side. If we differentiate, what we'll get? F dashed gx into g dashed x equal to 1. So put x equal to a. Let us put x equal to a. We are getting f dashed ga into g dashed a equal to 1. Given that ga equal to b and g dashed a equal to 5. These are given to us. Okay, so these type of twisting questions are very important, everybody. And for this type of examination, JEE Main examination, where calculus really does the matter, and we have to know the calculus, and we are doing the expected sums and some concept based question which may be hard, which may be easier, that does not matter. Matter is that we have to know some concept based question on calculus. Okay, we are doing today. And what to do, which implies that f dashed b equal to into 5 equal to 1. So f dashed b equal to 1 by 5. So here f dashed b equal to 1 by 5, this option. And differentiability, continuity, it is another important topic. And tomorrow we'll discuss about the analysis of the paper on JEE examination, what type of sums will be important, what we cannot say which is the important and which is the not important, but there are some guess that we can expect from which chapters are important. Tomorrow we'll discuss at the same time. Next sum, if f is defined on pi by 6 to pi by 3 and fx equal to root 2 cos x minus 1, yes, this continuity sum is very important, regularly coming in entrance examination paper. Okay, but really it is something boring, this chapter continuity, and we have to do some calculations. Let's see what can be done, but we have to solve the sum in the easy method. So what to be done? Here fx is the continuous at x equal to pi by 4. So limit x tend to pi by 4, fx equal to f of pi by 4 according to the question, which implies that limit x tend to pi by 4, it is coming root 2 cos x minus 1 divided by cot x minus 1 equal to k. It is in the 0 by 0 form. Whenever we'll get the formula, then prompt will use the formula. Otherwise, we should not take any risk. We can use the 0 by 0 form also. So everybody, we can use the L'Hopital's rule and limit x tend to pi by 4. Here we can write minus root over of sin x divided by minus cos x square x equal to k. Therefore k equal to root 2 sin pi by 4 total divided by cos x square pi by 4. So what is coming? Therefore we can write this as k equal to root 2 into 1 by root 2 sin pi by 4, and cos x square pi by 4, it is coming here root 2 square. So what is coming? K equal to half. So option is the B. Next word for sum, fx equal to box x minus greatest integer function, and it is another most important portion for the entrance examination. So given that limit x tend to 4 minus, options are given here, limit x tend to 4 minus, fx exists, but x tend to 4, it means x tend to 4 plus and x tend to 4 minus waste. How to proceed? Let us move. What to be done here? Let's see here. In this case, fx equal to given here, fx equal to box x minus box of x by 4. So x belongs to R. So limit x tend to 4 plus fx, we can write x tend to 4 plus, it means x is more than 4. So x by 4 is something more than 1. So any box more than 1, answer is 1. Therefore, it is coming 4 plus, it means 4 minus 1 equal to 3. Next, let us put here limit x tend to 4 minus. Limit x tend to 4 minus. X tend to 4 minus, just lesser than, actually 4 minus h. If it is 4 minus h, we can write this as 4 minus h means that is 3. So, and x by 4, x tend to 4 minus, it is a fraction number. Fraction number, its box is 0. So, it is coming to be 3 minus 0. This is coming 3. So, also we can write this as f of 4 equal to what is coming? Box 4 minus, it is coming minus box of 4 by 4. Box of 4 by 4 is 1, that is 4 minus 1, 3. The function is continuous at x equal to 4. The function is continuous at x equal to 4. Okay, so the option number is coming to be D. Let us go to the next one. Let fx equal to a into mod of pi minus x plus 1 when x less than equal to 5, and fx equal to b into mod of pi x minus pi plus 3 when x is greater than 5. It is continuous at x equal to 5. Really continuous sum. The sum based on continuous may be something calculative, but you can expect. So how to solve this sum? Let us proceed. What will be the answer here? Let's proceed here. Fx equal to a into pi minus x. So f of 5, since fx is a continuous, f of 5 equal to limit x tend to 5 minus fx equal to limit x tend to 5 plus fx. So let us find the f of 5 first. First let us find f of 5. So what to be done? So a into pi minus 5 plus 1 equal to a into 5 minus pi, because 5 is more than pi and from the mod positive quantity is coming out. So that is equal to, we can write limit x tend to 5 minus fx. So we can write here, really what is given? Limit x tend to 5 plus fx, it is coming b into 5 minus pi plus 3. So same thing, b into 5 minus pi plus 3. So we can write here a into, we can equate a into 5 minus pi plus 1 equal to b into 5 minus pi plus 3. So a minus b into 5 minus pi equal to 2. So a minus b equal to 2 by 5 minus pi. 2 by 5 minus pi. So option number A. If we can proceed properly, sum is not very hard, everyone. Let's go to the next sum. Let us go to the next sum. What is given here? Let f R to R be differentiable at C belongs to R and f of C equal to 0. And fc equal to 0 and gx equal to mod of fx at x equal to c, and about g, differentiability about g. What to be done here, everybody? Let us proceed with this sum. So first of all, it is given that we have to find the g dashed c. So you also answer, everybody. Next, g dashed c. G dashed c equal to what we'll write here? Limit h tend to 0 mod of f of c plus h minus mod of f of c total divided by h. So here it is given and f of c equal to 0. It has been given to us. So what to be done here? What to do? limit h tend to 0 mod of f of c plus h by h as f of c is 0 given to us. It is given to us that f of c equal to 0. Therefore, now we can write this as here limit h tend to 0 f of c plus h minus f of c. So f of c to 0. So we can write here divided by h. I have divided by mod. H I have taken to be mod. Since I have taken to be mod h, so mod of h by h. So this is coming limit h tend to 0 mod of h by h. It is 0 if f dashed c equal to 0. So g will be differentiable at x equal to c if f dashed c is 0. So what should be the option? Option number C. And this continuity and differentiability sums, really number of sums are coming in this type of papers. Let's go to the next, this type of sum, and this is very easy sum for us. This sum is very easy sum. What to be done? Simple. dy dt, dx dt, dy by dx, and accordingly double derivative. We have to do this first very. So we can write this as x equal to 3 tan t and y equal to 3 sec t. Otherwise sec square minus tan square we can do this. But in entrance examination paper we have to do the sum very fast, whatever type you think. So dy dx directly I am doing this. Achha, okay. dy by dt is coming to be 3 sec t. Okay. Dy by dt is what? 3 sec t tan t. One type of, whenever this type of sums are coming, this paper becomes very interesting. 3 sec square t. So let us get the dy dx. What is coming dy dx here? Tan t by sec t equal to sin t. Now let us go to the double derivative. Sometimes whenever we'll get the easy sums, it becomes very interesting also, right? So let's do one thing. So d2y dx square equal to cos t dt dx cos t 1 by 3 sec square t. We are getting, sorry, here it will be cos cube t by 3 at t equal to what? Pi by 4. At t equal to pi by 4, double derivative y2 equal to, that is cos cube pi by 4 by 3. It means 1/3 1 by 2 root 2. And indirectly we have to write the sum very fast, and we have to solve the sum very fast directly. Okay, let's go to the next sum. This type of sum is very important. More than important, it is interesting sum also. So fx equal to max of minus mod x. If we just provide a minus to any card, the curve is inverted with respect to the x-axis. So mod x we know. So minus mod x is this curve. Everybody, minus mod x is this curve. Achha, first of all, let us get y equal to root over of y equal to, actually it has been the printing mistake, it will be the minus root over of 1 minus x square. So minus root over of 1 minus x square is there in the JEE paper. It has been printing mistake from our end. Sorry very much. So let's do one thing. So y square equal to, actually it is a circle, part of the circle. So prompt you have to understand all these things. It's a part of the circle. So it is coming y square equal to 1 plus x square. Y square equal to 1 minus x square here. So x square plus y square equal to 1. It is a circle. So in this case, in this type of circle, this is the circle, and since it is a negative portion, so it's lower part of the circle, and the minus mod is this part. Minus what? So we can say here that negative, this is a max of the this part. It means this portion full. Okay, I am giving some another ink so that we can understand properly. This portion, So by diagram only we can solve the sum. So if we use the diagram, we have seen that clearly it is non-differentiable at the 3 points only. Just at 3 points it is non-differentiable. One is this point, one is this point, and one is this point. At 3 points it is non-differentiable. It means between -1 to +1 there are 3 points only where it is the non-differentiable. So it is the option number D. Let's go to the next sum. Let S be the set of the points in -pi to pi at which the function fx minimum sin x comma cos x is not differentiable. Then S is the subset of which of the following? S is the subset of which of the following? So what can be done here? So first of all, it is mean. Sorry, it is not max, it's mean. In this case, to get the mean sin x cos x in -pi to pi, so let us draw the sin x. This is the sin x curve, and then if we draw the cos x curve, so between -pi to pi only 2 points, so -3 pi by 4 and pi by 4. So just directly we can say this is the pi by 4 and this is the -3 pi by 4. So pi by 4 and -3 pi by 4 is in which set? Pi by 4 and -3 pi by 4 is in which set? It is a set number. Here it is pi by here it is pi by 4 and here it is -pi by 4. So option is the B, the subset of, because it is non-differentiable at -3 pi by 4 and pi by 4. So in case of differentiability, one very interesting thing is there that we can solve the sum by diagram drawing. Once we can do the diagram properly, we can solve the sum very easily. Okay, so let us proceed to the next sum. Next sum is there. Let fx equal to cos x, x1, 2 sin x, x squared 2x, and it is a limit. First of all, we have to get the fx, and by expansion or by determinant property, better is the expansion because we have the short time in our hand, and then we can just do the f dash x. After that, we'll see what can be done, right? So first of all, let us expand. Fx equal to, so what to expand? Just simple expand the determinant, x square minus 2x square minus x into 2 sin x minus 2x tan x, and everybody very fast expand. It is very much important. Expand very fast. Plus 1 into 2x sin x minus x square tan x. So this is the minus x square cos x plus other terms are cancelled and x square tan x. Okay, so if we take the x square common, we are getting x square tan x minus cos x. Examination is very near at hand and I have to solve the sum first. And if you are calculation doesn't matter really in the examination paper. Okay, so let's proceed. So f dash x in the u by v method, what is coming? 2x tan x minus cos x uv method plus x square sec square x plus sin x. Our target limit x tend to 0 f dash x by x. So we can write this as limit x tend to 0 here, that is 2x tan x minus cos x by x plus x square sec square x plus sin x divided by x. So it is coming very fast. Calculate very fast. It's a simple limit, 2 into minus 1 plus this is 0. So answer is coming to be minus 2. So option number is where? Option is where here? This is the option number B, second option. Let us go to the next one. this type of sums, it has been given here, fx equal to sine inverse 2 3 to the power x, whenever inverse circular function, whenever it is related to the inverse function, what we have to do, that is we have to search for some formula. 2 tan theta by 1 plus tan square theta. Directly we can put the value. So let us apply. So we can write this as sine inverse, directly let us do this. Sine inverse 2 e to the 3 to the power x by 1 plus 9 to the power x equal to, what is coming? This is coming tan inverse 2 tan theta by 1 plus tan square theta. Okay, so we are getting here 2 tan inverse 3 to the power x. Now f dash x, I am doing directly sum. I am doing sum very fast. Okay, so everybody understand this. So f dash x is coming what? 2 by tan inverse x is 1 by 1 plus x square. So 2 by 1 plus 9 to the power x into 3 to the power x log 3. Okay, so f dashed minus half, what is coming here? Root 3 into half log 3, that is root 3 log of root 3. So option, what is coming option here? Check it. This is another one more sum, previous JEE paper. So what to be done? Just differentiate. What is coming? U equal to tan inverse 6x root x by 1 minus 9x cube. X belongs to 1 to 1/4. And how to calculate? This is tan inverse 2 into 3. Let us get the form. X to the power 3 by 2 total divided by 1 minus 3 x to the power 3 by 2 whole to the power 2. So yes, it is getting satisfied. That is 2 tan, according to the formula, 2 tan theta by 1 minus tan square theta. So tan 2 theta, like that. That is in this inverse 2 tan inverse x form. So 3 into x to the power 3 by 2 form. Therefore, differentiating with respect to x, if we differentiate with respect to x after simplification, so tan inverse means 1 by 1 plus x square. So accordingly substitute. It is very easy sum everybody. Okay, and do it very fast. Whenever in the entrance examination paper we'll get the easy sum, first target should be we have to do that sum only. So 1 plus 9x cube into 3 by 2 into x to the power half, that is 9 root x by 1 plus 9x cube. So we can write this as root x into gx. This is equal to root x into gx. So root x into gx equal to coming 9 equal to 9 root x by 1 plus 9 x cube. So directly gx find, that is 9 by 1 plus 9x cube. This differentiation very important for the examination, entrance examination. Okay, let's go to the next sum. This type of sums are very common for the examination. So let us proceed with this sum. So better in this type of cases if we take the log on the both side. It will be the best for us if we take the log on the both side. So what we'll do? M log x, that we can do. That you can solve easily. Do it before me. Plus n m log x plus n log y equal to m plus n log x plus y. Let us differentiate. Directly we can do, and I have done so much time this sum. I can remember this sum. I can learn this sum. So directly I can do this. dy dx, if we apply, n by y minus n plus m by x plus y equal to m plus n by x plus y. I have done simple dy dx and take dy dx in the right hand side and left hand side, take common dy dx, and we are getting this. And this sum is generally is in the school book. So whenever we'll get this type of sums, be prompt to get the answer. Very fast answer for this type of sums. Nx plus ny minus my minus ny total divided by y into x plus y equal to same thing here, that is mx plus nx minus mx minus my by x into x plus y. So divide and do the calculation simply. I know the result. I have done several times this sum in different places, different it is in different book. Okay, so I can remember the answer. I am writing this, but you must calculate this sum. Y by x. Okay, let us proceed with the next sum. Fx equal to 1 minus tan x total divided by 4x minus pi x not equal to pi by 4, and x belongs to 0 to pi by 2. Fx is continuous, and then f of pi by 4. We are doing some expected questions from previous year, because there are a lot of PYQ question previous year's paper. So let us do some expected and different category, different types sums. Okay, ready? Let us solve. So in this case, we can write this as, what we'll do? Limit x tend to pi by 4. Simple, I can multiply 1 minus tan x was there, multiply 1 plus tan x in the numerator denominator, divided by 1 plus tan x in the numerator denominator into minus 4 pi by 4 minus x. Okay, so we are getting limit x tend to pi by 4. If I take a minus common, we are getting tan pi by 4 minus x into 1 plus tan x divided by 4 into pi by 4 minus x, tan x by x equal to 1. Answer is coming minus half. Sum is so fast. You have to do the sum very fast. You have to solve the sum very fast. Let's do the next sum. This type of sums, which is very common for the exam, what to do? Is a continuation. We can write this as x equal to e to the power y plus e to the power y plus e to the power y. So we can write x equal to, let x equal to e to the power, that iteration in this continuation is y. So x equal to e to the power y plus x. Therefore, just differentiate whenever variable is in power only one way, that is you have to take the log, but it is another way also there. As you think better what you do, right? So in this case, what to be done? 1 by x. If you take log on the both side and differentiate, directly I am doing 1 plus dy dx. So we can write dy dx equal to 1 minus x by x. Let's come to the next sum. Which of the following points lying on the tangent to the curve at the point 1, 0? How to solve this? So in this case, in this particular case, which of the following points? First of all, let us get the tangent, then we'll check. First of all, we have to get the tangent, then we'll check. So what to do? X to the power 4 e to the power y plus 2 into root over of y plus 1 equal to 3. Differentiate karo. UV formula, x to the power 4 e to the power y into dy dx plus e to the power y into 4x cube plus 2 by 2 root over of. Whenever we'll get this type of sums, differentiation, everybody done this. So we can solve the sum. At 1, 0 we can get, at 1, 0 we can get dy dx plus 4 plus dy dx equal to 0. So dy dx equal to minus 2. So equation of tangent is what? Y minus 0 at 1, 0. At 1, 0, y minus 0 equal to minus 2 into x minus 1. Therefore, 2x plus y equal to 2. Now check the option. Let us check the point and option. So which point and which option is there? If we see the option number A, B, A is not satisfying, B is not satisfying, C will be satisfying, D is not satisfying. So option is a C. Although we have got the C, then also let us check the D if it is there. Okay. Although it is a single option correct type. Let's the next sum. The equation of the normal to the curve sin y equal to x sin pi by 3 plus y at x equal to 0. This type of sums are very straight sum, and in this straight sum we have to solve directly. Differentiate dy dx minus dx dy and according to the point wise. Start solving everyone. We have what? Sin y equal to x into pi by 3 plus y. Simple differentiate karo. Cos y dy dx equal to UV formula x into this is coming sin of pi by 3 plus y. Sin of pi by 3 plus y. So UV formula cos y dy dx, that's x into cos pi by 3 plus y into dy dx. This is a very simple and straight sum, plus sin of pi by 3 plus y. Okay, so this is number 1, and put x equal to 0 and y equal to 0 here. We are getting dy dx, put x equal to 0 and y equal to 0. We are getting here dy dx equal to what? 3 by root 3 by 2. Therefore, minus dx dy equal to minus 2 by root 3. As fast as possible, you have to do the dy dx and double derivative. Now, just equation of the normal passing through 0, 0 is y equal to mx minus 2 by root 3 x. Therefore, 3 root 3 y equal to minus 2x. See the option? Option is A. This type of straight sum we have to solve very fast. Let's go to the next one. What is the next sum telling? Angle between the tangents to the curve y equal to x square minus 5x plus 6 at the point. Y equal to x square minus 5x plus 6. It means this is a quadratic expression, the parabola, and tangent at the point. Okay, so this point is suppose 2, 0, and this on the x-axis, and this point is 3, 0, and if we want to draw the about perfect type, this is the way we have to get the angle between the tangents. This angle between the tangents is needed. So let us do one thing, dy dx. Let us get the value. Dy dx equal to what? Y equal to x square minus 5x plus 6. So 2x minus 5. Let's m1 is dy dx at 2, 0. So 2, 0 is what? 4 minus 5 equal to minus 1. And m2 is dy dx at 3, 0. So dy dx at 3, 0. So what is coming? 6 minus 5, that is coming to be 1. And m1, m2 equal to minus 1. So the tangents are perpendicular to each other. Tangents makes the angle pi by 2. Application of derivative. Very important. Lot of chapters are there. And it is extremely important. And tomorrow we'll analyze the paper. We'll discuss what to be done for the JEE examination. Let the normal at a point P on the curve y square minus 3x square plus y plus 10 intersect y-axis at 0, 3 by 2. Is m is the slope of the tangent. M is the slope of the tangent. Then mod m. What to do? Let P is any point. P is any point x1, y1. Suppose P is any point x1, y1 on the curve, and let us do the differentiation first. So 2 y1 minus 6x plus y1 equal to 0. So y1 means divide x. y1 equal to 6x1. Put the value x1, y1. 1 plus 2 y1. This is the divide x. So slope of the normal is minus dx by dy. Slope of the normal is minus dx by dy, and let us equate this. Therefore, y2 minus, it is passing through, what is coming here? It is passing through the point 0, 3, 2. So let us equate slope of the normal and the normal at P, and suppose this point is T. Let us equate. Therefore, we can say here that slope of the normal 3 by 2 minus y1 by minus x1 equal to, according to the slope of the normal we got here, 1 by minus 1 by tangent, 1 plus 2 y1 by 6x1. Okay, so let us cross multiply. We are getting what? 9 minus 6 y1 equal to 1 minus 1 plus 2 y1. Therefore, y1 equal to 1. So x1 equal to, when y1 equal to 1, x1 equal to what? Plus minus 2. So slope of the tangent is what? Slope of the tangent equal to plus minus this. We got slope of the tangent y1. Okay, so plus minus 12 by 3, that is plus minus 4. So m is the slope of the tangent. Its mod m is 4. Sum is over. Let us go to the next one. Let us do the next one. Let fx equal to 3 sine to the power 4x plus 10 sine cube x plus 6 sine square x minus 3x belongs to minus pi by 6 to pi by 2. F is regarding that increasing decreasing of the function. We'll decide and we'll proceed. Okay, let us do one thing. First of all, we have to do the f dash x, and if we go to the f dash x, we are getting directly you can use trigonometrical function as you think better. So 12 sine cube x, directly I am doing cos x, plus 30 sine square x into cos x plus 6 sine square x. 6 sine square x is 2 sine x cos x, that is 12 sine x cos x. That is coming, if we take the common, sin x cos x, 6 sin x cos x better if we take common, sin x cos x, we are getting 2 sin square x plus 5 sin x plus 2. So if we just do the factorization of this thing, this is 2 sin x plus 1, sin x plus 2 is discarded. I can cancel here. I am cancelling this sin x plus 2. Therefore, if I just apply the method of interval or Weber-Curve theory as you think better, okay everybody, therefore, which is the option? Decreasing in minus pi by 6 to 0 and increasing in 0 to pi by 2. So minus pi by 6 to 0 is the option here. We'll proceed in this way. Let's do the next one. So what to do here? F is a real valued function defined on R except minus 1 and plus 1, given fx equal to log of x minus 1 by x plus 1 minus 2 by x minus 1, then regarding the increasing decreasing function. Regarding the increasing and decreasing of the function. So first of all, we have to do the f dash x. Let us find the f dash x. Directly I am doing this. F dash x equal to what? 3 x plus 1 by x minus 1 into 2 by x plus 1 whole square plus 2 by x minus 1 whole square. That is coming to be, if we cancel, go to the cancellation, it is coming what? 6 by x square minus 1 plus 2 by x minus 1 a whole square. If we do the LCM, what we are getting? 6 into x minus 1 plus 2 into x plus 1, right? That is x minus 1 whole square into x plus 1. Therefore, f dash x equal to 4 into 2x minus 1 divided by x plus 1 into x minus 1 whole square. Now let us check the calculation, and while checking the calculation, f double dash, not double dash, sorry, it is f dash x. F dash x is greater than equal to 0. Under what condition? If we drop the wavy curve, that is minus infinity, minus 1, half. So this is coming plus, this is coming minus. So f dash x is greater than equal to 0. It is coming what? It is coming x belongs to minus infinity to minus 1 union half to infinity except 1. So option number B is the right option. Let us do the next one. Fx equal to x by square plus x square minus d minus x by root over b square plus d minus x whole square, where these are the constants. Then regarding the increasing, decreasing, continuous, so we have to check everyone. Let us check it. And for checking, only one thing is there. We have to just get the first derivative. So everybody, first derivative is what? X by root over a square plus x square minus d minus x by b square plus, we need just tremendous practice for solving this type of sums. Okay, so let us go to the f dash x. You can apply u by v method. I am doing directly because this particular type x by a square root over a square plus x square we have done number of times in the class. Okay, so I can do that directly. You should do that directly because we have practiced all these things in the class regularly. U by v formula, it is coming a square plus x square whole to the power 3 by 2 plus b square, it is coming b square plus d minus x. These sums we have done several times in the class, which is greater than 0. So for every x belongs to R, so it is an increasing function. It is an increasing function for every x belongs to R. So what should be the option? Option is C. The function f defined as, which is given fx equal to x cube minus 3x square. These are the straight sum, and you have done number of times this sum. So whenever we'll see this type, first of all we have to look at which is the easy sum, and we'll proceed like this. Okay, and we'll make one analysis and how to act in the examination hall, how to proceed in the examination hall. So we'll discuss tomorrow in this type of live class, and tomorrow just we'll discuss what to be done. Next one. So here we are getting fx equal to x cube minus 3x square plus 5x plus 7. So if we do the f dash x, we are getting 3x square minus 6x plus 5. So absorb all the x to make a whole square. If we absorb all the x to make a whole square, x minus 1 whole square plus 2, which is greater than 0. Always for every x belongs to R. So it is an increasing function. So option number, this is B. Let us go to the next one. If x equal to sin to the power 4x plus cos to the power 4x, then fx is increasing in the interval. What to do? Simple derivative and do the as fast as possible the differentiation. So what is the f dash x here? Sine to the power 4 plus cos to the power 4, that is sine square x plus cos square x whole square minus 2 sine square x cos square x. 1 minus half sine square 2x. If we differentiate the 1 minus half sine square 2x, we are getting what? That is 1 minus half, okay, I am writing sine square 2x. So this is fx. So f dash x is coming what? This is coming minus 4 sine 4x. So fx is increasing when f dash x should be greater than 0. So minus 4 sine 4x should be greater than 0. So sine 4x should be less than 0. So x belongs to pi by 4 to pi by 4. In this way you have to proceed. Okay, let us do the next. So the number of distinct real roots of the equation 3x to the power 4 plus 4x cube minus 12x square plus 4 equal to 0. Number of distinct real roots, this type of sums are very important. That number of solution, number of distinct roots, these are extremely important, this type of sums. So what to be done? First of all, let us differentiate. That is important. Directly I am differentiating. On differentiation, what is coming here? 3x to the power 4, that is 12x cube plus 12x square minus 24x. So if we take 12x common, x square plus x minus 2, that is coming 12x, x plus 2 into x minus 1. So if we apply the Weber-Curve theory, method of interval, plus minus sign, as you think better. If we can do this, this is coming 1, this is coming 0, this is coming minus 2. So this. So this is negative, this is positive, this is negative, this is positive. Sign of fx. Therefore, we can write this as. So we can say here in roughly that zero, this is 1, this is minus 2. So fx has a minima at x equal to minus 2, minima at x equal to minus 2 and x equal to 1. Fx has a minima at x equal to minus 2 and x equal to 1, and fx has a maxima at x equal to 0. Therefore, fx will cut the x-axis at 4 points. So it has 4 distinct real roots. So it has 4 real roots. Distinct real roots. Let us go to the next one. The maximum slope of the curve occurs at the point. Maximum slope of the curve occurs at the point. What to be done? So directly let us do the dy dx. Dy dx means slope of the curve. So directly slope dy dx 2x cube minus 15x square plus 36x minus 19. So this is our function m. We'll do its derivative d2y dx square equal to 6x square minus 30x plus 36, and for actually this is dm by dx, we have to make dm dx equal to 0. If we make dm dx equal to 0, we are getting x equal to 2 and 3. And if we do the double derivative of the m, it means d3y dx cube. Dx cube, it means d2m by dx square. If we do the double derivative, we are getting 6 into 2x minus 5. So at x equal to 2, d2m by dx square is coming what? Equal to minus 6, that is less than 0. Hence max at x equal to 2. So at x equal to 2, y equal to what? Put the value half 2 to the power 4. It means half 2 to the power 4, 16 minus 5 into 2 cube, 8 plus 18 into 2 square, 4 minus 19 into 2. So this is coming what? Here we are getting 8 minus 40 plus 72 minus 38. So 72 plus 8, 80, 38 plus 8, 46. So we are getting what? 38, 30 plus 38 plus 40 is 78. Answer is coming 2. So required point is, this is why. So required point is 2, 2. Therefore we can write this as point is 2, 2. Done. Point is 2, 2. Therefore, what is the final answer? Option number D. Let's go to the next one. Whereof length 2 units is cut into 2 parts, which are bent respectively to form a square of the side x unit and the circle of radius r units, if the sum of the area of the square and the circle so formed is minimum, then you have to get some relation. How to solve this? What to do here? Let's see. According to the question, we are getting 4x plus 2 pi r equal to 2. So we can say r equal to 1 minus 2x, r equal to 1 minus 2x by pi. So area equal to x square plus pi r square equal to x square. Just put the value. What is coming? Pi square 2x minus 1 whole square. Therefore we can write for max mean, first derivative make it 0. This is 2x plus 4 by pi, 2x minus 1 equal to 0. So x equal to 2 by pi plus 4. So it is it needed to check? Obviously it will be the result and automatically it will be coming greater than 0. So not to check here. So this is maximum at x, this is greater than 0, so it is a minimum, not maximum. This is minimum. Therefore, if we compare here, if we compare, we are getting x equal to 1. If we compare these two, we are getting x equal to 1. So option number C. Let us go to the next one. This type of sums are very frequent for the examination. What is given? Let f r2 are given by fx equal to k minus 2x if x less than equal to minus 1 and equal to 2x plus 3 when x greater than minus 1. If x has a local minimum at x equal to minus 1, then the possible value of k. What can be done? What can be done here? Limit x tend to minus 1 plus fx equal to 1 and f of minus 1 given here k plus 2. So fx has a local mean. Fx has a local mean if at fx has a local mean at x equal to minus 1 if f of minus 1 plus greater than equal to f of minus 1 greater than equal to f of minus 1 minus. So this is the condition for the maximum minimum. Local max, local mean. Therefore we can write 1 greater than equal to k plus 2. Therefore k plus 2 less than equal to 1. Therefore k less than equal to minus 1. So this is one value. One possible value is this, k equal to minus 1. So option number 4. So in calculus, whatever we are seeing, that it is a very vast and we have to be prepared, and our target will be, question is not very hard, but there is something calculation, some calculative, but if we can get the easy question there, so nothing can be done. Okay, so let's go to the next sum. The value of the integral minus 1 to 1, whenever we get this easy question, this property based question, okay, everybody, there is nothing can be done. And nothing can be better than this. So this is odd function. This is coming 0 directly, we can say, because we know that minus a to a fx equal to 0 if fx is a odd function. Let us go to the next one. Now, properties of the definite integral, another important and very important. Another important as well as very important. So next sum. let px x square plus bx plus c be a quadratic polynomial. It means quadratic equation, quadratic expression with real coefficients such that 0 to 1 px equal to 1 leaves a remainder when remainder 5 when it is divided by x minus 2. Then you have to get some value. How to do this one? First of all, p of 2 equal to 5. Let us apply, given that px equal to x square plus bx plus c. So p of 2 equal to 5 means 2b plus c equal to 1, and calculation should be very fast. Also given 0 to 1 px, 0 to 1 px dx equal to 1. Therefore 0 to 1 x square plus bx plus c dx equal to 1. Therefore if we do the integration, x cube by 3 plus bx square by 2 plus cx 0 to 1, we are getting to be 1. So if we multiply upper limit and lower limit, instead of x1, instead of x0, it is the lower limit is 0. Instead of x1, if we put here, we are getting what? And if we do the LCM directly, 3b plus 6c equal to 4. Therefore this is suppose number 2. From number 1 and number 2, if we solve here, 2b plus c equal to 1 and b plus 2c equal to 2, and if we multiply 2 there, and if we solve, we are getting what? B equal to 2 by 9, and if we put b equal to 2 by 9 and c is should be what? C is 5 by 9. Now therefore what is our target? Our target is 9 into b plus c. So we are putting here, so 9 into b plus c equal to, we are getting 9 into 2 by 9 plus 5 by 9, that is 7. Let us go to the next one. The value of the integral 1 to 3 box function, yes, what can be done here? It's the box function case, greatest integer function case. And if you ready, in those my students are saying this, we have done a lot of sums on the box function, so we can expect the box, mod, fraction, root. These are very important for the entrance examination, which can change the nature of the examination. So we should be prepared on this. Okay, so let us proceed with this. What to be done? It is the greatest integer function. Absorb all the x to omega whole square. Always whenever x square, that quadratic expression is in any place, we have to apply absorb all the x to omega box x. Absorb all the x to omega whole square. And outside whole square there will be only constant. Outside whole square there will be only constant. So we can write this as 1 to 3 box of x square minus 2x minus 2 dx. Absorb all the x to omega whole square, 1 to 3. This is coming x minus 1 whole square minus 3 dx. Using x minus 1 equal to t, dx equal to dt. So let us change the limit. When x is 1, t is 0. When x is 3, t is 2 directly. Sometimes we have very less time in our hand and try to solve the sum very directly. Okay. So tomorrow we'll decide, we'll talk regarding in the examination hall. So therefore we can write 0 to 2 box of t square dt minus 3 1 to 3 dx. So box of t square 0 to 2, it means 0 to 1, 1 to root 2, root 2 to root 3, root 3 to 2. 0 to 1, 0, 1 to 2, 1 dx, 2 to root 3 to root 2 to root 3, 2 dx, and this is coming 3 dt. Dx dt same thing, definite integral. So dx and dt, it does not matter. Okay, name is not the matter, that we know. dt minus 6. What is coming? This is coming to be root 2 minus 1. First part is 0, root 2 minus 1 plus 2 root 3 minus 2 root 2 plus 6 minus 3 root 3 minus 6. That is coming minus 1 minus root 2 minus root 3. That is the answer of the question. So, definite integral is another most important. In calculus, we can categorize into two parts. One is the definite integral and another is the differential equation, and third part and the most important is the application of derivative with the differentiability. These are the main. Next one. What to do? This type of sums, very direct, very fast to answer. So, what to solve this sum? If we generalize, directly I am solving this sum. Generalize limit n tend to infinity. This is 0 to n minus 1. 0 to n minus 1, n by n plus r whole square. So, we can write this as directly 0 to 1. Direct, because in entrance examination, we have no any time. If it would have been the board examination, then we can do like this. So, this is coming whole square. So, it is coming minus 1 by x plus 1, 0 to 1, that is coming half. Regarding this, to my students, I am telling, regarding this, short tricks and tips books has been given. Must read this. This is the time where you need this book. Okay? Next sum. This type of sum. Minus pi by 2 to pi by 2 cos square x by 1 plus 3 to the power x. Whenever this type of sum is there, whenever denominator is some exponential is there, 3 to the power x, e to the power sin x, 2 to the power x. So, one way is that minus a to a fx dx equal to 0 to a fx plus f of minus x. It should be the target. So, what to be done here? That is 0 to pi by 2 fx cos square x in 1 plus 3 to the power x plus 1 plus 3 to the power minus x. 3 to the power minus x means 1 by 3 to the power x. So, it is coming 0 to pi by 2 cos square x dx. Everybody, we have to do like this. We have to solve sum like this. So we can write this is coming to be what? Cos square x, that is half 0 to pi by 2 1 plus cos 2x. But if you know this, this is coming directly pi by 4. 0 to pi by 2 cos square x is directly pi by 4. Similarly for the sine, these type of short things we have to keep in mind. We have to learn it. Next one. This is summation of n equal to 1 to 100, integration of n minus 1 to e to the power x minus box x, the fractional x, e to the power fractional x, and the period of the fractional x is 1, we know. So, using the periodic function property, we can write directly summation of n equal to 1 to 100, n minus 1 to n, e to the power fractional x, period of fractional x is 1 equal to 1. Therefore, we can write this as summation of n equal to 1 to 100, 0 to 1 e to the power x, that is 100, e minus 1 e to the power x, upper limit minus lower limit, e to the power 1 minus 1. In this way, very fast in short step. Next. Next question, minus pi to pi mod of pi minus mod of x. What to be done? First of all, let I equal to 2 into 0 to pi mod of pi minus x between 0 to pi. First of all, this is the even function, and between 0 to pi, so it is mod x, obviously pi minus x. Okay, mod of pi minus x. So we can write this as 2 into 0 to pi. Mod of pi minus x means pi minus x. Between 0 to pi, it is lesser than pi, so positive quantity is coming out. Okay, so we are writing like this: 2 into upper limit. If we just integrate, we are getting x square by 2, 0 to pi. So 2 upper limit minus lower limit, pi square minus pi square by 2. That is coming pi square. Pi square. Whenever we are getting the opportunity to do the sum first, so we'll do the first sum now. এখনই তো আমাদের কাজে লাগবে. It is the time we need this to solve the sum first and all the tricks. And the trick book which has been given to you, everybody, my students, those who are my students seeing this, the short tricks books which has been given at the last moment, you see this. This sum. Let's solve this sum. Let I1 equal to, not let, already it has been given, I1 equal to 0 to 1, 1 minus x to the power 50 whole to the power 100 dx. And this is I2. Achha, better instead of I1, let us proceed with the I2 and we'll get the I1. It will be better for us. So better let us start with the I2. Let us start with the I2. So I2 equal to 0 to 1, because we'll get from I2 we'll get I1, because we have to do the by parts. So you are getting I2 equal to 0 to 1, 1 minus x to the power 50 into 1 minus x to the power 50 whole to the power 100 dx. So in this case we can write this as, if we separate this, it is coming 0 to 1, 1 minus x to the power 50 whole to the power 100 dx minus 0 to 1 x to the power 50, x into x to the power 14, because we need to do the by parts. For by parts we have to keep v integrable function. So here we are writing 1 minus x to the power 50 whole to the power 100 dx. So suppose this is the first function and this is the second function. Let's go to the by parts, and this is I1. Therefore we can write I2 equal to I1 minus UV formula x into 1 minus v constant, u constant derivative integration of v 50 into 101, 0 to 1 minus, we are getting a derivative of u integration of v on total dx, that is 1 minus x to the power 50 whole to the power 101 by 50 into 101 dx. Okay, everybody, this, whenever we are going through the basic, that is the by parts formula application, our target is to do very fast. We'll try to do the sums very fast. That should be our target. Okay, so here we are getting here, therefore I2 equal to I1 minus, if we apply, we are getting what? We are getting this side 1 0 0 and 0, so I1 minus you are getting what? I2 by 50, because I2 is coming out. So 5051, I am taking I2 in the left hand side, so 5051 plus I2 by 5050, so 5051 by 5050, I2 equal to I1. Therefore alpha equal to, according to the question, alpha equal to I2 by I1 equal to 5050 by 5051. 5050 by 5051 in which option? Option number C. I was continuously thinking for some times that why option C is not coming too much. Option A we are getting, option B we are getting, option D we are getting, but option C we are not getting too much. So this is the time we got the option C. Next one. Let f 0 to 5 to r be the continuous f1 equal to 3, f be defined as fx equal to 1 to x t square gt, it means we have to apply the Newton-Leibniz formula. It is another important chapter, important portion. Newton-Leibniz formula will come later. So gt equal to 1 to t fu du, and at x equal to 1, so discuss about the minima, maxima, critical point, inflection. For this, first of all, let us proceed with the differentiation. Let's see. gt equal to 1 to t fu du, therefore g dash t equal to f of t, derivative of upper limit, function of upper limit, Newton-Leibniz formula we are applying, and g1 equal to 0. g1 equal to 0 because we can write this as, if we put g1, so 1 to 1 integral, it is coming to be 0. That is why g1 equal to 0. Now it has been given that fx equal to 1 to x t square is gt. So f dash x equal to x square gx. Therefore f dash 1 equal to 1, f dash x, f dash 1 into g1 already 0. We got g1 to be 0 here. We got g1 to be 0, so it is also 0. It is getting 0. Now we are writing that. Now we can write here f double dash x equal to 2gx into x plus x square g dash x, every formula. Now we can write g dash x equal to fx. So f double dash x equal to 2x gx plus x square g dash x equal to fx. So we are putting here x square fx. So we can write this as f double dash 1, we are writing, this is coming 0. G of 1 equal to 0. Put x equal to 1, g of 1 equal to 0, and plus x square fx. Therefore f double dash 1 equal to 1 into 3, that is 3. It means we can see it is a very good conceptual sum which has been given. Very good conceptual sum it has been given. Here it has been given that f dashed, we got what? We got f dashed 1 equal to 0. We got f dashed 1 equal to 0. Just see, the very good conceptual question is there. We got f dashed 1 equal to 0, and f double dashed 1 is positive. It means it has minima. It has local minima at x equal to 1. Where is the point here? Local minima. The local minima at, it has a local minima. It means C. It's a very good concept sum. That f dashed 1, here we are seeing that f dashed 1 equal to 0 and f double dashed 1 is coming 3. It means it is a minima, positive. So it is a case of minima. Next sum. Let us go to the next sum. Integration 0 to 3 tan x by root over of 2k sec theta, tan theta by root over of 2k sec theta, d theta equal to 1 minus 2, then the value of k. Very simple sum. Very simple sum. So what to be done here? Simple. We have to integrate. So 0 to pi by 3 tan theta by root over 2k sec theta. If we break it into sin theta cos theta, given 1 minus this, so 1 by 2 root k, if I take outside, and if I just put sin theta cos theta in terms of tan theta as sin theta by cos theta, so we are getting sin theta by root over of cos theta d theta equal to 1 minus root 2. Therefore minus, if we take cos theta equal to t square, directly we can get the integral. Apply the short tricks, everybody. আমাদের শর্ট ট্রিক্স অ্যাপ্লাই করতেই হবে। অ্যাপ্লাই দ্য শর্ট ট্রিক্স। It is a time that you have to win over the match. So minus root 2 by root k into 1 by root 2 minus 1 equal to 1 minus 1 by root 2. Therefore k equal to 2. Sum is over. Let us go to the next one. The value of the integral. Try to solve it. The value of the integral minus 2 to 2 sine square x by pi by x. Yes, Ronak, after a long time. So I'll talk to you later. Let us finish the class, and Ronak will call me after the class. After 2:30, you call me once. I'll talk to you in details. Absolutely. Let's do one thing. The value of the integral minus 2 to 2 sine square x by pi plus 2. So let us apply here. Same thing, minus a to a fx dx equal to 0 to a plus 0 to a fx plus f of minus x. Let us apply this point. So I equal to, let I equal to, we are getting here 0 to 2, 0 to a fx plus f of minus x. So sine square x, we are getting here x by pi plus half plus sine square minus x is sine square x, that is minus x by pi of x by pi plus half dx. And we know that box x plus box of all properties of the box is very important, all properties of the box. Now we can write this as I equal to, so here we are getting sine square x 0 to 2 box of x by pi plus half plus sine square x minus 1 minus box of x by pi plus half. So it is coming to be 0. Answer is coming to be 0 if you add. They are getting cancelled. Let's go to the next one. Whenever this type of sums are very important. Jantala, just some tea. Save me some tea. So, everybody, n tend to infinity, n by n square plus 1. These type of sums are very frequent. If we see the last PYQ of the JEE Main examination, so we see these type of sums are very important, very frequent. So, let us get directly limit n tend to infinity, summation of r equal to, just match first term and last term. This is very important. First term and last term in r equal to 1 to what? That is the most important. R equal to 1 to 2n, that is n by n square plus r square. This type of short tricks you have to practice before the examination, because these are very probable sums. So we are getting here n tend to infinity, therefore we are getting directly 0 to 2 dx by 1 plus x square, that is a tan inverse x, 0 to 2, so upper limit minus lower limit tan inverse 2. Option number 8. Next, go to the next sum. One such similar sum, minus pi by 2 to pi by 2, and one denominator is some exponential function. Whenever this type of sum is there, so minus a to a fx dx equal to 0 to a fx plus f of minus x. Directly we will apply, and already once a sum we have done previously. So 0 to pi by 2, if I take sine square x common, we are getting 1 plus 2 to the power x, 1 plus 2 to the power minus x dx. That is coming 0 to pi by 2, this pi by 4. 0 to pi by 2 sine square x, 0 to pi by 2 cos square x equal to pi by 2. These type of things are very important. We have to remember, we have to keep in mind. Let's go to the next one. This is what sum. I1 equal to 0 to 1 e to the power minus x cos square x, I2 equal to 0 to 1 e to the power minus x square cos square x, I3 equal to 0 to 1 e to the power minus x cube dx, and which is greater and which is lesser. Greater and lesser part. There are two ways to solve the sum. One way is that we can do the just about cos square x, cos x in this way, and cos square x is common here. So e to the power minus x e to the power x square, if we draw the indirect curve. Okay, rough curve. Indirect curve means rough curve. Otherwise, normal way we can proceed. So the normal way is that x here lies between 0 to 1. We have to keep in mind. X is between 0 to 1. Here, x is between 0 to 1. That is important. So x cube less than x square less than x. If we do a minus x cube greater than minus x square greater than minus x. Now, just multiply cos square x. So e to the power minus x cos square x greater than e to the power minus x. So sign will be changed here. Cos square x less than e to the power minus, because cos square x is a fraction mainly, between 0 and 1 it is a fractional case. So this is cos square x. So sign will be changed here, e to the power x cube. E to the power minus x cos square x, e to the power. So here it is coming e to the power minus x cube. Now we can say e to the power minus x cos square x less than e to the power minus x square cos square x less than e to the power minus x cube. So I1 less than I2 less than I3. It means I3 is the biggest. Where is here? I3, I2, I1. Option number D is the last option. Let us go to the next sum. Let's proceed the next sum. This type of sum is very, very easy sum, and whenever we should expect this type of sums, first target is that we solve the sum first. So there are a number of ways to solve the sum. We can multiply 1 plus cos x in the numerator denominator. Otherwise we can do one thing. We can write 0 to pi by 4 to 3 pi by 4 here. It is pi by 4 to 3 pi by 4. We can apply a to b f x dx, a to b a plus b minus x. That is also possible. So we can write this. Okay, I am solving the sum 1 plus cos x. So 0 to a to b f x dx equal to a to b f of a plus b minus x. That is also possible. So this is coming pi by 4 to 3 pi by 4. We are getting dx by 1 plus cos of pi minus x. Okay, that is coming pi by 4 to 3 pi by 4 dx by 1 minus cos x. Now add first and second, this and this add. If we add 2y, because the limit is same, type is same, so we can apply, and these are very easy sum also. This is coming 2 by 1 minus cos square x. If we add this, because denominator, if we add, we are getting 1 minus cos square x. That is here coming sin square x, it is coming cosec square x, and with cosec square x, we can solve it minus cot x. So this is coming minus cot x. So it is pi by 4 to 3 pi by 4. It is coming to. Definite integral is very important, and we must get not only one sum, we may get more than one sum also. So it should be ready with the definite integral. At the last moment, what to be done, we'll discuss tomorrow. This is a sum which has been given 1 to x log t by 1 plus t, then fx plus f of 1 plus x equal to what? So put t equal to 1 by z. Therefore, dt equal to, directly I am solving this sum, minus 1 by z square dz. So, fx equal to 1 to x log z by z square into 1 plus 1 by z dz. So, we are getting here 1 to x log z total divided by here log z by z into 1 plus z dz. Therefore, fx plus f of 1 by x equal to 1 to x log z into 1 by 1 plus z plus, instead of t we can write z also. It does not change the nature of the reaction and nature of the sum. Therefore, we can write this as 1 to x log z by z dz. So, log z whole square by 2. This is 1 to x, that is log x whole square by 2. Service over. Let us go to the next sum. 0 to pi box of conics. Box of conics. What to do? Let us write 0 to pi box of conics. So let us apply king property or property number 4, whatever you think. So king property, if we apply 0 to pi cot of pi minus x box. So 0 to pi minus cot x dx. So if we add I plus I to I equal to 0 to pi box of cot x plus minus box of cot x, box of minus cot x. So we can write here box x plus, for any x which is not integer, box x plus box of minus x equal to minus 1. We can apply this concept here. Therefore, we can write this as 2I equal to 0 to pi minus 1 dx. Therefore, I equal to minus pi by 2. Box function is very important. Next up. The solution for the x for the equation root 2 to x dt by t into root over of t square minus 1. It's a JEE Main question. This is related to the very basic question. Okay. So this is direct sec inverse x formula. So directly we can write this as sec inverse t root 2 to x, that is pi by 2, that is sec inverse x minus sec inverse root 2 equal to pi by 2. Okay, thanks. Equal to pi by 2. Not needed now. Not needed for me. So therefore you can write sec inverse x equal to pi by 2 plus pi by 4, that is 3 pi by 4. So x equal to minus root 2. If you are not comfortable with the, if you are x equal to minus root 2, if you are not comfortable with the sec inverse, so go to the cos inverse. Right? Let's go to the next sum. Let us go to the next sum. 1 to the power limit n tend to infinity, 1 to the power p plus 2 to the power p plus n to the power b n plus 1. So for this type of sum, so we can do directly, we know this sum. Directly we can write limit n tend to infinity 1 by n summation of r equal to 1 to n. So r by n whole to the power p, that is x to the power p. X to the power p, that is 1 by p plus 1. Directly we can solve this sum. Let's do the next sum. This is a very good sum. Pi to 10 pi mod of sin x. The period of mod of sin x is pi. So let us start with 0 to 10 pi and minus 0 to pi. That is also easier method in one line method. So we can write this as pi to 10 pi mod of sin x. We can write this as 0 to 10 pi better because 0 to nt The properties of the property of the function is 0 to nt. Is n 0 to t, where t is the period. Here period of the mod sin x is pi. So we can write this as, we can 0 to 10 pi mod of sin x. So we will subtract 0 to pi because we have already, it has been from pi to 10 pi. So minus 0 to pi mod of sin x dx. So mod of sin x 0 to pi is 2. Area of mod of sin x between 0 to pi 1, look, it is 2. Area is 2. Area of mod of sin x 0 to pi is coming 2. So therefore we can write 10 into 2 minus 1 into 2, that is coming 18. Directly we are getting the result. Option number 2. So ready? Let us do the next sum. This is one sum of, again, containing the box function, and it is a very good conceptual sum. How to solve this sum? Mod of integration of 0 to root pi by 2. Root pi by 2, it means pi by 2 equal to 1.57. And root pi by 2, suppose root pi by 2, it means root over of 1.57. You can take approximately 1.2. Those will give the advanced examination. For advanced examination, you have to remember some data, some value. So you have to keep in mind all these things. So root pi by 2 is about 1.195, like that. Or we have no calculator. So you have to learn something. Okay. So in this case, suppose it is, think this as 1.2. Therefore, we can write this as box of 0 to root over of pi by 2, box of x square minus cos x. Box 0 to 1, between 0 to 1 and 1 to root over of pi by 2. Root over of pi by 2, think as a 1.2, 1.1, 1.3, whatever it is. You can decide. So 0 to 1, this is coming to be minus cos x. So minus cos x means this is the cos x. Cos x curve will be inverted, minus cos x. And between 0 and 1, 0 and 1, box x square is 0. And 0 and 1 minus cos x is this curve. This is pi by 2, 1.57. This is 1. So between 0 and 1, this is the minus cos x curve. So this is coming minus 1. Therefore, we are getting, here it is minus 1 dx, and between 1 to root over of pi by 2, 1 to 1.2, 1 to 1.2 is here. 1 to 1.2 here. This is x is 0 as well as the value is 0. That is 0 dx, whole mod. So we are getting to be 1. Sums are not very hard, but this is something twisting, some tricky. Limit sum, try to solve it. Try to solve it ready. Limit is also very important chapter for the JEE examination. And not only limit, full calculus is important. So let's proceed. Given limit x tend to infinity, root over of x square minus x plus 1 minus x equal to b, and we have to get a and b. First of all, let us rationalize this. If we multiply by the rationalizing factor, so I am multiplying. So if we multiply by the rationalizing factor, we are getting limit x tend to infinity. So root over of x square minus x plus 1 minus ax into root over of x square minus x plus 1 plus ax divided by root over of x square minus x plus 1 plus ax. If we multiply equal to b, so numerator is a plus b into a minus b square formula. So we are getting here limit x tend to infinity x square minus x plus 1 minus a square x square total divided by root over of x square minus x plus 1 plus ax equal to b. This limit exists only if a square equal to 1. Why? Because limit x tend to infinity. Limit x tend to infinity, value is finite number. Whenever value is finite number, we have to write like this. Numerator is x square. We have to immediately cancel the x square. Otherwise, limit will go to the infinity. But the answer is some finite number. So a square should be 1. Then only x square should be cancelled. This you have to remember like this. So a equal to plus minus 1. A square equal to 1. A square equal to 1. So a equal to plus minus 1. A equal to plus minus 1. Now just let us proceed with this. So finally what is coming? By putting the value of x. So limit x tend to infinity. We are getting what here? That is minus x plus 1 by root over, because x square portion is coming to be 0. So we are getting x square minus x plus 1 plus ax. A is coming, plus ax equal to b. So let us divide by x. If we divide by x, we are getting here what? Minus 1 plus 1 by x total divided by root over of x square. If we divide by x, we are getting here 1 minus 1 by x plus 1 by x square plus a equal to b. So we can write minus 1 by 1 plus a equal to b. To exist b will exist here if a not equal to minus 1, because denominator should not be 0. So a not equal to minus 1. If a not minus 1, so a equal to 1. If a is 1, b is minus half. If a is 1, b is minus half here. B is minus half. Therefore, the ordered pair is 1 minus half. So here we are getting ordered pair is coming 1 comma minus half. So first option. So continuously number of times we are getting only the first option. Next sum. Let's solve it. Let us solve this sum. Limit is, everybody, limit is under our control. Money we have done, everybody done the limit. Limit is not very hard chapter, and we have to limit, you will get almost, and we have to do the limit sum properly. Okay, because it is not very hard sum. First of all, we'll try to get the formula, use the formula. If it is not there, then we will apply the L'Hopital's rule or any other way simplification and all the things. Let us go to the next one. So limit x tend to 0 sine square pi cos to the power 4x. What to be done? Sine square, directly I am solving. Sine square limit x tend to 0 sine square pi cos square x whole square divided by x to the power 4. So we can write this as limit x tend to 0 sine square. We can write pi cos square is 1 minus sine square whole square divided by x to the power 4. Now if we expand, we can write limit x tend to 0 sine square pi plus pi sine to the power 4x. We are expanding minus 2 pi sine square x total divided by x to the power 4. So we can write limit x tend to 0 sine square x equal to sine square pi minus 6. Sine x equal to sine pi minus 6. That also we can think like this. So we can write this as sine square. we can write here pi minus pi 2, just wait, pi minus pi into 2 sine square x minus sine to the power 4x. Total divided by x to the power 4. Otherwise, you can differentiate, but better method I am showing you. Now you decide what will you do. So instead of differentiation, try to solve the sum. So sine square pi 2 sine square x minus sine to the power 4x. Okay, by we can write here pi square sine square x by x square. So I am writing numerator denominator same thing, that is 2 sine square x minus sine to the power 4x. This is coming whole square into balance by the same. Sine square x by x square is 1. That concept, 2 sine square x minus sine to the power 4x whole square by x to the power 4. This part is 1. This total part is 1. Sine square x by x is 1. 1 pi square is will be there. Therefore, we can write this as here pi square, and if I take from the bracket sine square x common, so sine to the power 4x by x to the power 4, 2 minus sine square x whole square, that is pi square, into 2 minus sine square x. If we put the value, we are getting here directly 4. Sum is over. Directly 4 pi square. And whenever this sum is related, I have done of my own, you can do of your own. As you think better, you can start directly differentiating. As you think better that you can solve the sum very fast, it depends on you. Okay, next sum. If alpha equal to limit x tend to pi by 4 tan cube x minus tan x by cos of x plus pi by 4 and beta equal to limit x tend to 0 cos x to the power cot x. What is this? Cos x to the power cot x. That is 1 to the power infinity form. Cos x to the power cot x means 1 to the power infinity form. We can apply e to the power fx form also, as you think better. You can apply e to the power fx also. So let us get the value first. After that we will decide. So alpha equal to limit x tend to pi by 4 tan cube x. If I take tan x common, if we take minus tan x common, we are getting 1 minus tan square x. Total divided by, if I just open the cos formula, 1 by root 2. If I take cos x formula, directly cos x minus sin x. If I take cos x common, we are getting 1 minus tan x direct. Everybody, this is the entrance examination and you have to solve the sum very fast. Okay, next. So we are writing this as, if we cancel 1 minus tan x, so we are getting limit x tend to pi by 4. What is coming here? That is minus root 2 tan x into 1 plus tan x by cos x. Just put the value, minus root 2 into 2 into root 2, that is minus 4. This coming minus 4. Also beta is cos x to the power cot x. So beta can be written as 1 to the power infinity form. E to the power fx form we can write as you think better, 1 plus x whole to the power 1, as you think better in different ways. So we can write this as here. What? E to the power fx cos x minus 1 into cos x by sin x. By sin x, limit x tend to 0. That is coming to be limit x tend to 0. What to do? 1 minus cos x 2 sin square x by 2. So minus 2 sin square x by 2. Cos x is cos x as it is, nothing, it will not be affected, and sin x is 2 sin x by 2 cos x by 2. Sin x by 2 cos x by 2, and if we cancel sin x by 2 in the numerator denominator, we are getting e to the power 0, that is coming 1. We got alpha, we got beta. Alpha, what we got? What is coming alpha? It's minus 4. alpha is coming to be minus 4, alpha is coming to be minus 4, and beta is coming to be 1. Now let us come to the main part of the sum. Are the roots of the alpha beta are the roots of this equation, then the a and b. So if you ready, let us get sum of the root minus b by a. Now let us proceed like this. Sum of the root minus b by a and product of the root c by a minus 4 by a. So minus 3 equal to minus b by a and minus 4 equal to minus 4 by a. Therefore a equal to 1, b equal to 3. Therefore we can say a and b is 1 and 3. Sum is over. Sum is over. Let us go to the next sum. If R2R be a continuous function, then limit extend to pi by 4 2 to sec square x. It means it is a Newton limits formula. It is the Newton limits formula. Okay. So what to do? Limit extend to pi by 4. Pi by 4. The sum is what? 2 to sec square x fx dx total divided by x square minus pi square by 16. It is in the form of 0 by 0. Therefore, apply the Newton limits formula, L'Hopital's theory. Using L'Hopital's theory, we are getting limit x tend to pi by 4. What is coming? Pi by 4. Derivative of the upper limit, function of upper limit, minus derivative of the lower limit. This lower limit is already 2, its derivative is 0. Therefore, we can write this as f of sec square x into 2 sec square x tan x total divided by 2x. Just now, let us put the value. There is no chance of getting denominator 0, so we can directly put the value. Therefore, pi by 4 f of 2 into 2 into 2 total divided by 2 into pi by 4, that is 2 f of 2. So final answer is what is coming? Option number C. Let us go to the next sum. Instead of, in this type of sums, limit extend to 0, x by 8, 0. So instead of rationalizing, better, let us, it is in the form of 0 by 0 though. Yes, it is in the form of 0 by 0. So instead of directly, instead of using this rationalization, let us directly differentiate. Okay. So what to be done? Directly I am doing. Suppose L equal to limit, I am writing again. Limit extend to 0, x by 8th root of 1 minus sin x minus 8th root of 1 plus sin x. So we are getting limit extend to 0, limit extend to 0, 1 by, if we differentiate, minus cos x by 8 into 1 minus sin x whole to the power 7 by 8 minus cos x by 8 into 1 plus sin x whole to the power 7 by 8. So if you do the LCM of this, what we are getting? Limit x tend to 0, 8, 1 minus sin x into 1 plus sin x, 1 minus sin square x. So we are getting 1 minus, actually it is cos square x, okay. 1 minus sin square x whole to the power 7 by 8 total divided by minus cos x into 1 plus sin x whole to the power 7 by 8 plus 1 minus sin x whole to the power 7 by 8. So that is 8 into 1 into 1, just put the value, total divided minus 1 into 1 plus 1, that is coming 4 is the final answer. Final answer is coming to be 4. let's do the next sum. What is coming? Limit x tend to 0 plus cos inverse x minus box of x square into sin inverse x minus box of x square. You have to get the result. X tend to 0 plus, whenever x tend to 0 plus, then x equal to 0 plus something, that is 0. But if it would have been x tend to 0 minus, we could write minus 1, h minus 1. Okay, it is 0 plus, this is, we can write box x equal to 0. So directly we can write this as limit x tend to 0 plus cos inverse x into sin inverse x total divided by x minus x cube. So we can write this as limit x tend to 0 plus cos inverse x by 1 minus x square into limit x tend to 0 plus sin inverse x by x. Sin inverse x by x is 1 and cos inverse x by, just directly put the value. Everybody, we can put here directly we can put here, and sin inverse x by x is 1. So directly if we put the value, we are getting here we are getting what thing? That is pi by 2 into 1, that is pi by 2. So everyone, for the time being, I am leaving, and tomorrow let us discuss regarding the examination details, how to proceed in the examination, what to do in the examination hall, analysis, everything will detail discuss in the next one. So bye everybody.